Okay, hi guys. So I'm going to start by going through the homework from either Thursday or Friday, depending on when you had maths. Um, since this is a live lesson, I'm going to go through question 4. I'll probably pause the video, come back to you, see if you have any questions, and so on and so forth. I just thought it might be nice to have a recording of the class, and I know the Schoology recordings expire, so I'm just going to try this. We'll see what it's like. If it doesn't work, it doesn't work. Okay, so the first question. A 5-tile repeating pattern made up of shaped tiles is shown. So it goes triangle, square, circle, triangle, circle, and then it's going to go again, triangle, square, circle, triangle, circle. So that's 6, 7, 8, 9, 10, and then it will go again. Yeah? Okay, so copy and complete the following table. Shape number 1 is a triangle. You can write the word or draw the shape, whatever. Shape number 2 is a square. Shape number 3 is a circle. Shape number 4, a triangle. And shape number 5 is a circle. The 6th tile, you can actually see it there. So the 6th tile is a triangle. The 10th one, I think I can see in what I did as well. So the 10th tile is going to be that. So that's a circle. Now the 21st tile, okay, so this is where we're going to have to use that kind of logic that I used in the last question the other day. So see here, if you can spot kind of a pattern within the pattern. See here, number 5 is a circle. It's actually the last part of the sequence. And then number 10 here is also a circle. And if I keep going, 15 would be a circle. So what we're saying is that the multiples of 5 are circles. Okay, and they're actually the last circles because there's obviously 2 circles in the pattern, so the last circles. So 5 is going to be the last circle, 10 is going to be the last circle, 15 is going to be the last circle, 20, 25, they're all going to be that last circle. Okay, now if we look at this question, we're looking for the 21st. Okay, so we know that the 20th, look, it's over here. The 20th tile is a multiple of 5, so that means the 20th tile is going to be this part of the pattern. See where I am there? So then the 21st is just going to be next. So it's going to be a triangle. And explain your answer. The explanation of my answer is this. Multiples of 5 are the last circles in the pattern. So if 20 is a circle, then 21 is obviously next, which is a triangle. Okay? Grant. So we move on to question 6. A repeating pattern made up of shaped tiles is shown. The pattern repeats after 6 tiles. Okay, so here we have, I'll go black, 1, 2, 3, 4, 5, 6, and then it will start again. So the 7th one will be the red triangle, the 8th one will be the blue square, and so on. Okay? So, tile number 1. The shape of tile number 1 is a triangle and the colour is red. The shape of tile number 2 is a square and the colour is blue. The shape of tile number 3 is a circle and the colour is green. Tile number 4 is a square and we're back to red. Tile number 5 is a triangle and blue. And tile number 6, well, should I draw it the right way? It's still a triangle, technically, and all they're asking me about is the shape, but I suppose if I'm drawing it, I may draw it upside down. And it's green. Okay, so what is the shape of the 10th tile? Okay, that should be easy enough to do in terms of just counting. So 1, 2, 3, 4, 5, 6, back to here for 7, 8, 9, so there's 10. So what is the shape here? We're talking about a square. Yeah? 15 is probably fine too. We'll keep going. So that's 11, that's 12, then back to the top, 13, 14, 15. So 15 is going to be, let me try and put this in. This one. What are they asking me? Color. So the color is green. Okay, so what's the color and shape of the 37th? Right, I'm not going up to 37th, so I'm going to start looking at my my pattern again. So if we grab a highlighter, so the 6th one is your upside down green triangle. Look, so is the 12th, and if I were to continue that one, 16, 17, 18, so is the 18th. Okay, so the 6th, the 12th, the 18th. What would be next? They're multiples of 6, so 24th, the 30th, the 36th. All of these are upside down green triangles. Yeah? Sorry, I just want to make sure I'm doing this in the right place. I think I am. Yeah, I am. My iPad's not working today. Not to worry. Right, so what colour is the 37th? Okay, well, if we look here, the 36th is an upside down green triangle. So the 37th is right after that. And right after the upside down green triangle, we go back to the start. So colour and shape, it's going to be a red triangle. Yeah? So how many times does the green circle shape appear in the first 27 shapes of the pattern? First 27. Okay, so it's going to appear, let's go with green since it's green. So the green circle, is that right? Yeah, so this one here, green circle. So it's going to appear in this one. It's going to appear in this one, so that's 2. It's going to appear in this. Do you know what I mean when I say this one? So the first sequence goes from 1 to 6. The second sequence goes from 7 to 12. The third one goes from 13 to 15. And every time it's the third, so it's like it's here, it's here. It will appear in here to bring us up to 24. Okay, so we definitely have 4 to bring us to 24. Then the 25th is going to be this one. This is the 26th and this is the 27th. So we get another one. So it's 1, 2, 3, 4, and then this one over here, 5. So 5 times. And why? Again, because the pattern repeats every 6. So it appears once in the first 6. It appears once in the second 6. So now we're up to 12. It appears once in the third pattern. So now we're up to 18. It appears once in the fourth 6, so now we're up to 24. And then the green circle is the 27th shape. So that's your fifth one. So 1, 2, 3, 4, 5 of them. Okay? Right, I'm going to see if I can go back to my iPad. It's just a bit like, woo! Just dropped my pencil. Let's not worry. Okay. Okay, we go full screen there. Let's see if this will work this time. Right, seems to be working. Okay, so I'm just gonna go down, get that out of the way. So Monday, what are we talking about? The date is today, 5th, 6th, so it's the 8th. Okay, that's just for homework at the end of class. Okay, so we will go in here and we did the shapes. So today's class is called Linear Patterns. Right. So, a pattern that is given as an ordered list is called a sequence. Can you see that over there? Okay, a pattern, actually that wasn't the best choice of colour, was it? Try this one. Yeah, it's a bit better. So a pattern that is given as an ordered list is called a sequence. And then if it's a pattern of numbers, it's called a number sequence. Okay, so when they give it in a list like this one over here, then you have a number sequence, okay? So that there is a number sequence, which is essentially, it's a set of numbers with a pattern written in a list. Okay, a set of numbers with a pattern written in a list. Okay? Another kind of important point is that each number or each bit of the sequence is called a term. Okay? So the first term, you can see it here, actually they've done it. The first term of that sequence is 6, the second term is 10, and so on. Okay, so we refer to them as terms. And then the last word that hasn't been addressed really is the word, go on, yep, linear. Okay, and what linear means is that there is a common difference between each term. There is a common difference between each term. Okay, so when we look at the numbers 6, 10, 14, 18, so we're calling this a pattern, which means it must be predictable, because do you remember that's what a pattern is? So for a pattern, So for a pattern, you must be able to predict the next term. Okay, so can we predict the next term? We can, and the reason we can is because we have a common difference. Okay, so if we look to go from 6 to 10, what's the jump there? That's a jump of +4. To go from 10 to 14, that's a jump of +4. To go from 14 to 18, that's a jump of +4. So if we want to predict the next term, can we? Yep. We go +4, and we can tell you then that the next term in this sequence is 22. Okay, so that's what the linear bit is. Okay, it is a linear sequence if it has a common difference between each number in the sequence. Okay, every single jump has to be the same in order for it to be a linear pattern. Okay. Now, we're not going to do this just yet, but I do want you to make a note of the fact that the reason sorry, I hate the way they've written that. I'm going to take it off. Okay, so I'm going to write it myself. So, the reason it is called a linear pattern is because if you put the numbers on a graph, they form a straight line. Look at those words, the word linear and the word line. Okay, so the reason we call it a linear pattern is because if you were to plot the numbers, so the numbers 6, 10, 14, and 18 on a graph, they line up, all those dots line up in a perfect straight line. Okay, now I'm going to show you how to graph them, but not today. All right, so this is all we're going to do today. A couple of predict the next terms. Okay, so let's have a look. We have 11, 18, 25, and 32. Okay, according to the question, these are linear sequences. Okay, so if they're sequences, that means they're patterns. And if they're patterns, that means they're predictable. So we can get the next term. Okay, if they're linear, that means we should have a common difference. Okay, and what that means is that the jump between each number should be the same, and that's the device we're going to use to predict the next, what do they want? 3 terms. Yeah? Okay, so let's do it. So from 11 to 18, that's a jump of 7. From 18 to 25 is 7. From 25 to 32 is 7. So we have a common difference of 7. That tells us that this is a linear sequence. And if we were to put these numbers on a graph, they would line up. Yeah? Okay, so let's predict the next 3 terms. So we're going to take 32 and we're going to add 7. And that should give us 39. And then we're going to take 39 and we're going to add 7, which gives us 46. Agreed? Okay. And then we go one more time and we add 7, and I think that gives us 53. Okay. The next one is a bit harder. 2 minus 1 minus 4 minus 7. And I want the next couple of terms. Right, we'll change colour here. Okay, so to go from 2 to minus 1, we might just, let me just, hang on. Okay, I don't know what colour I'm in here. Okay, that's fine. Okay, so I'm just going to throw a few numbers onto this, just a number line. We'll just go minus 7. Okay, so we go yeah? Right, so this sequence starts on 2 and we want to go to minus 1, okay? So it starts here on 2 and we want to go to minus 1. So that is 1, 2, 3. So that's 3 jumps to the left, which means we're going down. So that there, from that to that, is minus 3. Okay, so let's look at the next jump. So now we are here on minus 1. And we're trying to get to, what's next? Minus 4 is next. So let's have a look. 1, 2, and again, 3. So that's good. That's minus 3. Yeah? So now we're going to go from minus 4 to minus 7. So we're here on minus 4 and we want to go to minus 7. So 1, 2, and again. That is 3. Okay? So, do we have a common difference? Yes, we do. The common difference here is minus 3. So just that the sequence is going down and not up. That still means it's a linear sequence. Once you have a common difference, you have a linear sequence. And it still means that I have a straight line graph. If I were to graph it, or when I will graph it. It's just, I suppose, in this one up here, hang on. Red, insert, arrow. In this straight line graph, it would be a graph that's going up like that. Whereas, let's get a yellow. In the second one, the graph would be going down. Okay, because the numbers are getting smaller. Okay, so let's see, can we get the next number? So if we go down another 3 from minus 7, we get minus 10. If we go down another 3, we get minus 13. And if we go down another 3, we get minus 16. So they're the next 3 terms in that sequence. Yeah? This is just something I want to draw your attention to. It's not hard or anything. It's just describing in words. Sometimes they ask you to describe a sequence in words. Okay, so I put the kind of solution here because I want you to know what needs to be included. So there are three things. First thing, what type of sequence is it? I've obviously so far only shown you one type of sequence, but you will learn more. So the first comment you need to make is, what type of sequence is it? Okay. Second one is, where does the sequence start? So what is the first term or the starting term of the sequence? And then the third one is, how do you get from one term to the next? So that is your common difference. Yeah. So for this sequence, let's have a look at it. So it starts there at 7. To go from 7 to 10, that's plus 3. To go from 10 to 13 is plus 3. And from 13 to 16 is plus 3. So the fact that it has a common difference means we know what type of sequence is it. It's a linear sequence. The starting term is 7, and the common difference is plus 3, so it's going up by 3 each term. Okay, so they're the three comments you need to make. So describe this in your own words. It is a linear sequence with a starting term of 7, and it is going up by 3 each time, or each term. Yeah? Okay, so that's it. I'm just going to get you to practice a few of these for homework, really. So for this first one here, we're going to do 1A. You have to answer all of these questions over here on 1A. So for this first sequence here, what is the starting term? I don't want to tell you, but what is the starting term? What is the difference? So the first difference is another way of saying common difference. Okay, fill in the boxes for each sequence, finding the next 3 terms, and then write a sentence describing the sequence. So make sure that has the 3 points that I discussed above. Okay, so I want you to do part 1, 2, 3, 4, just for the first sequence. Yeah? I want you to do 3A. I want you to do 4A, and I want you to do 5A. Okay, so 4 questions there for homework, and that's due for Wednesday. Okay, I'm going to pop it into the journal. Good. And go back and get the other bit. Okay. Right, so that's it. That's due for Wednesday, and let me know if you run into any problems while you're going through the homework. Okay. Thanks, guys.